Welcome to this video on descriptive epidemiology according to person, place, and time, based on Chapter 5 of Introduction to Epidemiology by Ray M. Merrill. In this lesson, we'll take the foundational concepts of descriptive epidemiology and apply them across the three key dimensions that guide all public health investigation: person, place, and time. This is where we begin to see the power of data storytelling in epidemiology. Our overview of person, place, and time. Descriptive epidemiology allows us to classify health events by who is affected, where it's happening, and when it occurs. This triad provides the structure for identifying disease patterns, monitoring health status, generating hypotheses for analytic studies. Each element, person, place, and time, offers unique insights into disease distribution and helps us prioritize public health action. Person, who is affected. The first element is person. This involves the characteristics of individuals who are affected by a health event. Descriptive data often include age, sex, race, and ethnicity, marital and family status, occupation, education level, religion, socioeconomic status. These characteristics help determine risk profiles. For example, cardiovascular disease rates increase with age, and some cancers are more common in certain racial groups. We also consider acquired characteristics such as immunity or lifestyle behaviors and activities such as occupation or recreational exposures that may influence risk. Understanding person-related data helps public health professionals tailor interventions, education campaigns, and health policy. Place. Where does it occur? The second element is place. This involves geographic or physical locations where the disease occurs or varies. This can be measured on many levels: country or region, state or city, neighborhoods, environmental settings like workplaces or schools. Comparisons between different locations can reveal environmental exposures, access to care, cultural influences, socioeconomic disparities. Studies may examine disease distribution before and after migration or compare twins raised in different settings. We also use tools like spot maps, heat maps, and GIS mapping to visualize place-related data. Time. When did it occur? The third element is time. Time data in epidemiology refers to when health-related events occur. Timing can range from hours to days in outbreak investigations, weeks to months in surveillance, years or decades in chronic disease studies. There are three primary types of time trends in descriptive epidemiology. First is secular trends, which represent long-term changes in health conditions. For example, declining heart disease mortality over 30 years. Second is cyclic trends, which are seasonal or repeating patterns. Think flu season peaking each winter or chickenpox cycles every few years. Third is short-term or point epidemics, like a sudden outbreak of E. coli after a picnic. These are often localized and time-specific. Time patterns allow us to understand exposure windows, incubation periods, and predict future trends. Epidemiologists' inference from descriptive data. Descriptive epidemiology is more than just counting cases. It helps generate hypotheses for further analytic research. When data are examined by person, place, and time, we can spot unusual trends, identify emerging health threats, form the basis for case control or cohort studies. This process is known as epidemiologic inference, drawing conclusions based on systematic observation of disease distribution. Data information message. Descriptive data is transformed into powerful public health messaging. Here's how. First is data. This is the raw count or measurement, like 1,000 measles cases. Second is information. When we add context, such as a 50% increase from last year, it becomes more meaningful. Third is message. This is where we interpret the information to answer, what does this mean to me? For example, data 1,000 measles cases. Information, that's a 50% increase. Message, vaccinate your child before their first birthday. This transformation helps drive public action and policy change. Special tools, population pyramids and dependency ratios. Two tools commonly used in descriptive epidemiology are: first is the population pyramid. This graph shows the age and sex distribution of a population and helps identify trends like aging or youth bulges. Types include expansive pyramid, high birth and death rates; constrictive pyramid aging populations, stationary pyramid stable birth and death rates. Second is the dependency ratio. It shows how many people are dependent relative to the working age population. Higher dependency means more strain on social and healthcare systems. These tools help predict service demand and inform health resource planning. To summarize, descriptive epidemiology classifies health events by person, place, and time. Person tells us who is at risk based on demographics and behavior. Place reveals geographic and environmental factors. Time helps us detect trends, outbreaks, and seasonal patterns. These three elements guide hypothesis generation, policy development, and effective intervention planning. Visual tools like population pyramids and dependency ratios enhance our understanding of population structure and healthcare needs. Thanks for watching. Be sure to subscribe and join us in Chapter 6, where we explore general health and population indicators, including life expectancy, mortality, and years of potential life lost.